Hey, what's up everyone? Welcome to Chapter 2, Constraints. It's a word you'll be hearing me say a lot. There are several different types of constraints, but in this chapter, we're going to take a look at the first 5 in the menu here. They just so happen to be the most commonly used constraints. But before we can start constraining things, I want to talk about one of the most basic relationships in the program. That is the parent-child relationship. On a transform level, remember our transform versus our shape nodes, the child does just about everything the parent does. It will rotate, translate, and scale along with its parent. So to demonstrate this, I'm just going to go ahead and create some polygon primitive spheres. I'll scale this up a little bit. We'll use nice even numbers to make it easier to see what's going on. I'm going to hit Control D to duplicate, and then I'm just going to move up my sphere and scale it down a little bit. Cool. To create the parent-child relationship, first select your child object, then just select the parent and press P. Now our small sphere is a child of the larger one, and will do all the same transforms that the parent object does. But it will still be able to move independently of the parent. The transforms are relative to the parent, so let me undo. If you notice, just before I parent the smaller sphere, the translate y is 10 and the scale is 2. But now look what happens. I press P, and our translate y is 1 and our scale is 0.2. That's because the transforms have just become relative to the larger sphere, which has a scale factor of 10. If I scale this back down to the original scale factor of 1, my smaller sphere now looks like it is resting on the y value of 1 here. One way to have our child not follow along its parent object is to turn off this attribute called inherits transforms. And that can be found in the attribute editor on the transform node. Here, it's this little checkbox. So if I click it, our sphere seems to disappear, but actually it's just going inside of the larger one. And now, if I move this large sphere, our child does not follow along with it. But if I turn it back on, it will snap right back into place where it was. The other way to have your child not follow along the parent object is to use constraints, and we'll get into that in the next lesson. Before we move on, I just want to mention that when I duplicated this first sphere, the construction history was not duplicated along with it. That is because by default, when you duplicate, direct connections are not duplicated. If you wanted to have that happen, you could go Edit, Duplicate Special, and duplicate input graph, and hit apply. And then you have the construction history duplicated as well. Also notice that by default, when you duplicate, just by doing Control D, you duplicate the entire hierarchy. So a couple spheres are created here. In the course materials for this chapter, I have provided a bicycle asset with the controls unorganized. Let's go ahead and open that now. I've gone ahead and hidden the node editor. For the rest of this lesson, we will not be making any direct connections or creating new nodes. Instead, we'll focus over here in the outliner. You can see that there are a bunch of unorganized control groups. Your goal is to create a hierarchy by parenting these controls to one another. At the end of this lesson, we'll want to make sure that every control lives in a hierarchy under this main global control. If you shift and click on this plus sign, it's going to expand the entire hierarchy. Shift click again, it's going to collapse the hierarchy. And if you don't have shift selected, it's just going to go one at a time. And that can be kind of slow when you're working with a larger hierarchy. You'll notice that I've padded this control with some extra transform nodes. It's usually good to do this when rigging because it helps you to organize and manage different types of connections. I put the constraint group at the top because, like I said earlier, constraints will override other relationships. Under that, we have some different offset groups, and using these is going to make more sense once we actually start to constrain things. But for now, let's just focus on the top group and the control. As we're parenting, we want to be careful to not break up these groups. Just like in the viewport, if you press F while focused in the outliner, you can hone in on what you have selected, and it's a lot easier to find things that way. So let's start by parenting these three controls together. What I want to do is take this guy, parent it to this one, and this one to the global. So let me start by working my way up. I'll take root 2, the top group of that, and parent it to the root 1 control. And you can actually just middle mouse drag in the outliner to create a child parent. So take the child, middle mouse drag to its parent. Now if I expand this, you can see they're all in one hierarchy together. It's good to give animators more than one global or root control. It makes it easier for them to handle any sort of offset of the entire character, vehicle, or prop, or whatever you're working on. Let's take a look at these arrows now. They're essentially, right now, functionality-wise, are going to do the same thing as our root controls, but we might want to use these later to attach to a motion path. And I want to explain that right now, but it's a good way animators can attach something along a curve and have it follow. So we're going to do what we just did. I'm going to take the second one, the top group, and parent it to its control. And then I'm going to work my way up here. So now it's just we're getting a longer hierarchy. But everything right now is following this root control. Cool. I'm going to expand this, make it easier to see things. Let's see what we want to do next. Probably don't want to do the wheels yet. Let's go to the cog. Now I put the cog, which is stands for center of gravity, right here. And on a bike, that's actually very dependent on a rider. So wherever their weight is going to really determine that. And there are a couple different cog controls, and that will allow the animator to shift, basically change where they want that to be. So giving them an extra layer of control is going to help them do that. So we'll do what we just did, actually. So I'm going to work my way up on these controls, making sure the first one is the parent of the second, and the second one is the parent of the third. Now, under the path control, we're going to put our cog. It's getting quite long here. We may not end up needing a constraint group on all of these, so we can go back in later and clean it up if we wanted. But let's just keep going now. So what's next? Basically everything here is going to function independently, but still we want it to be a child of the root. So I'm just going to start by taking everything we have left and putting it under the cog, the last cog. Cool. So now everything should just kind of follow along. Of course, the model is not moving yet because we're going to need to set up some constraints to make that happen. But let's keep working on our hierarchy first. So I'll just go down this list for the rest of the controls. So the steering control, we want the front tire to move with it because the tire is part of this fork, and when we turn with the handlebars, we want that to move too. And the back wheel, we don't really need anything underneath that. Just as long as it lives under the cog, we should be fine. So there are three pedal controls. We have a center one, and that's because we want, when we rotate, for it to move as one unit. So let's go ahead and take these pedals and parent them under the center one. You'll notice that there are these two hidden locators. Don't worry about that right now. Those are there for the next lesson on constraints. So let's just collapse that. And last but not least is our seat cushion. So we have this razor control, which is this little arrow here. And when we move it up and down, we want the seat cushion to come with it. So I'm just going to drag that in here. And that looks like it's it. We have our entire hierarchy. You can collapse it all, expand it all, and that's all of our controls. Let's just make sure it works. If I move this, everything should come with it, and that looks like it's doing it. And then the cog, all of the components of the bike should live under it still, so this should move the entire bike. Great. One last thing that I want to mention is that I did leave a little bit of a setup on this bike chain. If you rotate the center pedal control, you'll notice that the chain is revolving around the 2 gears. And I just wanted to call this out in case you notice some connections are being fired off. This is the only geometry that should be affected by any control right now. And I do want to elaborate on this setup a little bit later on in the tutorial. I think it's a really great example of where modeling, rigging, and scripting all cross over. But until then, thank you for watching, and I will see you in the next lesson. Hey everyone, welcome back. In this lesson, we will cover 4 out of the 5 most commonly used constraints, that is parent, point, orient, and scale. Aim constraints have a little bit more going on in them, so I think they justify their own separate lesson. And we actually don't need them for this bike, so it kind of works out well. Pull vector, we'll talk about this later on when we start to set up our limb. Rivet, this is new in Maya 2020, and I'm very excited about it. However, I understand that not everybody has a copy of 2020 yet, so I will refrain from using them in this course. Motion paths, I will talk about a little bit. This is actually what I use to set up the chain. Each link is following a motion path. And later on, we're going to draw a curve and use motion paths to attach our bike to that curve so it follows along the curved path. These ones here, we're not going to be using in this course, but basically there are different ways you can constrain objects to other types of geometry like polygons, NURBS, or curves. All right, I'm just going to click this bar up here to detach the menu because we'll be wanting to access this quite a bit throughout the lesson. Let's take a look at what's in our model group here. We have all the different parts as separate groups. And essentially what we're going to want to do is constrain our groups to our controls. I think it's a good idea to never constrain directly onto geometry. Even though this is a transform node, it's essentially the same thing as a group, but I think it's just a little bit more clean to avoid doing anything with this poly mesh icon or any kind of transform that's related to a shape. So if you display your shapes here, you can see that this is a transform and the shape lives under it. But again, I just think it's more clean to avoid doing constraints directly onto this transform that's attached to a shape. So I'll go ahead and turn off shapes now. And let's start by creating our first constraint, which is we're going to do an orient constraint, and you can think of that as like a rotational constraint. So with our control selected first, in the outliner, if you use control click, or it might be command click for Mac users, but I'm using Windows, so it's control click in the outliner for me to select another object. So your driver is the control, your driven is the group, and you want to select it in that order. I'll go ahead and click apply, and you can see that these channels in the channel box have turned blue, and that represents our constraint. So now if I select my control and rotate, you can see this rotates in all axes. And if I were to translate, it's not going to follow because we're only using the orientation constraint. We probably don't need it to do all axes. We actually just want it to go in one direction, one rotation axis. So to do that, we can actually tell our orient constraint to constrain in X. So go ahead and hit apply. So now, if I were to rotate, it's only obeying the x-axis. And ideally, you wouldn't want an animator to be able to pose the control like this because it would break your rig. So in the next lesson, I'll go over how we can clean up the channel box to provide the animators with something a little bit more clean and more manageable. Go ahead and undo that. We'll leave the constraint here, and let's start doing some other constraints. One thing I just want to point out is I know this doesn't look right. You would want your pedals to look flat. but I am getting a little bit of my head of myself. We'll go over that in just a second. But for now, let's do all the same rotate X constraints that we want. So what I mean by that is if you select your control and then control click in the outliner to select your group, you can hit G to repeat the last action. And the last action was an orient constraint. And when you use G, it's going to use the same parameters as the time you applied before. So go ahead and do that again for the left pedal. Hit G. And we'll do that for the front and back wheel as well. Go ahead and hit G. And we'll do that for the front. Cool. So now if I select these and rotate, these are going to rotate, and this is going to rotate. That's great. That's exactly what we want. So keep in mind, all our controls live in one hierarchy. They follow each other. And with the orientation constraint, if I start to rotate things, you are going to see that they are orienting, but this looks weird. And it's just because we're only looking at part of the picture. So let's continue constraining the rest of the bike, and then it's going to start to make a little bit more sense. Let's take a look at the seat next. We have our seat geo, and that is a child of the seat rod, and it's the same way in our controls. Let's go ahead and create a point constraint for this control because we want it to translate up and down. So if I go ahead and say, we'll open up my point constraint options, select with my control selected, and then go ahead and control select the seat. If you notice, the pivot of this group is down at the origin. If I were to constrain with maintain offset turned off, our group is just going to snap to the same position our control is in, which is not what we want for this seat. We don't want our geometry to move when we connect it. So let's see what happens. We'll go ahead and hit apply. See that pivot went from down here to up here. This is our group. So if I wanted that to get back, I'd have to move that here. So we want this offset baked into our constraint. So if I undo that, I'm just going to make sure this is turned on. And then go ahead and hit apply. Now, if I move this up and down, it slides along with it. So this is exactly what we want to happen. I'm just going to translate this up, and let's take a look at the values in our group. You can see it's translating in Y and Z. Well, that's weird because we're only translating Y. But if you notice, this is oriented differently than our group. So to get that movement, you actually have to move in two axes. You have to move it up and over. So if I were to actually limit my constraints to only one axis, say Y, it's not gonna work properly, and I'll show you why. Oops, select the control and then the group, hit apply. And now it's only gonna move in one axis, which is Y. So it's actually this group which is only moving in one axis, so it's only able to move up. And we want it to do both. So it's going to kind of compute where it needs to end up in space based off of this object's orientation. So go ahead and undo, and we'll turn on all axes. Great, cool. So now let's rig the seat. This control is the seat control, and we want to be able to rotate and translate this seat. So we need a parent constraint. Just like orient constraints are rotation, point constraints are translation, a parent can handle both. So let's go ahead and look at our options here. See, we have translate and rotate. So with our control selected, I will control select the group in the outliner and go ahead and hit apply. So if I rotate this, now it's going to rotate and translate. And it's still going to be a child of the seat bar. Great. Awesome. That's exactly what we want. What if we wanted to give them the option to scale the seat, maybe adjust the size for their character? So if I look at it over here, We can use the scale constraint to do that. But just keep in mind, this pivot is down here. So it might, let's just see what happens. All right, I'm going to create a scale constraint. And I'm going to do the seat geo. That's what we want to constrain with scale. All axes. We can turn maintain offset on. Go ahead and hit apply. Now it scales, but look what happens if I scale in one axis. Ooh, that's not working right. So if I wanted to tweak the shape of this to fit a specific character, I might need to change my grouping. So let's go back and look at it in this view. Our seat, in order to get it to scale in the proper axis, we need to move the group into this same location. So usually when I'm arranging my groups, I think it's good to get rid of the constraint just to prevent anything from breaking. We're just going to redo this. So I'll go ahead and hit delete. And I want this pivot to be where my control is. So one way to do that is actually use this control, and we're going to control select our group. So our group is selected second. And then I'm going to use a parent constraint with maintain offset turned off. So now this group is going to snap where my control is. If I go ahead and hit apply, you can see that. Oh, great. But our geometry has moved, and we don't really want that. If I delete my parent constraint, because we don't need that anymore, we have the offset we need. Our group is where we want it to be, and it has the correct offset values. Now, let's get our geometry back into place. If I were to unparent this, see these values, they get translated, they get transferred back onto the geometry when you take it out of the group. If I just zero this out, it's going to end up in the right spot. Cool. That's what we want. But now, let's put it back into the group and see what happens. You get very similar transforms, but it's the inverse transform of what it was before. Since it's in the right place and it's going to work now, our group is where we want it and our geometry looks to be where we want it. Only thing I would suggest doing is wiping these transforms so it's clean. It's just nice to not have any transform values on your geometry, I feel. So if I go to modify, freeze transformations, I reset that to 0. And you can see that there's a little offset too because of this group. But now, if you notice, we'll go ahead and redo these constraints. So let's do the seat razor first. Go ahead and do a point constraint. And this group, so let's take the seat control and do a parent constraint. And we can leave maintain offset on. However, there is no offset between the control and the geo group. So it really doesn't matter whether it's on or off. Generally, it's I think I more often, I'd say, use maintain offset. So I'll go ahead and leave that on so my settings save. Go ahead and hit apply. And now, if we do the scale constraint, our control and then the geo, go ahead and hit scale. Now, this should scale in the proper axis. Because what's happening is this scale is going on to this group. And because they're aligned, it's everything is working perfectly. It's basically doing the same transformation on the group. Cool. All right. Let's move on to the front of the bike next. So if I select this steering control, when I rotate that, I want the handlebars and the fork and the tire to come with it. Right now it's doing something weird, the tire, so we might want to rethink how that is being constrained. But first, let's go ahead and take a look at the group. I'll go ahead and collapse some of these, and we want to look at this one, front group. So select that. Notice my pivot is at the origin. So if we were to just say do an orient constraint, and we want it to rotate in Y. So if I set that to the Y-axis, hit apply, and rotate Y here, it is not doing what I want. Basically, this pivot is it's orient constrained from the origin, so it's offset. It's not where we want. One way to fix it would actually be doing something similar to what we did on the seat and adjusting this group and moving it here and orienting it to our control. We could do that, or we could be lazy and use a parent constraint instead. So to do that, you can actually just use a parent constraint, and I'll show you why that works. Go ahead and constrain it. You're still constraining it here, but when you rotate, because all your axes are constrained, it knows how to offset that point in space. So now if we look at the pivot, it's shifted over here. It has these translate and rotate values because it is offset in translate and rotate from our controls relative to where our control is. So this point has just rotated out into space over here. So it knows where to go because we're using a parent constraint. Now we can go ahead and fix our tires. I'm going to zero this out in the channel box. Just type 0. And let's take a look at our front and back tire constraint. So it's not this one, it's these two. I'm going to remove the constraints that are there. Even though they really only want to rotate forward, I think it is good to just use a parent constraint here instead. That way, the animator can do whatever they want, whether it's make the tire come off completely. Like if you were to get in a bike crash and somehow that popped off, they could do that. Or if you just wanted to add like some super subtle jiggle, even though it's technically braking, do something like that. Just to make it a little bit more appealing. Let's say you're going over a bumpy terrain or something, you can kind of cheat it that way. Okay, cool. So now these are parent constrained, and if you take a look at this control, this is all moving as one. That's what we want. Cool. Now let's try to get the whole thing moving as one. If I take one of these cog controls and move it, you can see that some of these are actually following along. If I rotate, you can see some things are following and some aren't quite following. You notice the stem of the seat, the razor, is not orienting, and that's because we're using a point constraint. The tires and everything else pretty much is using a parent constraint now. And that's why it's moving along with this control. Our pedals are still just oriented in X, so that's why they are only rotating in one direction. Let's go ahead and zero this back out. So now if I select this model group and I move it, and see only part is coming with it. That's because even though everything under this group is a child, like I said before, constraints will overwrite the transformations of a direct child-parent relationship. In fact, it's countering that position. So if I were to move this way out into space here, it's like 73 units, and then go back to this tire, I can see it's negated that transform. So it's actually just moved it back to this point. So go ahead and zero this back out. And what we want to do is constrain the model to our rig. So to do that, we actually want the innermost control, which is going to be the third cog. So if you go in order of hierarchy, you have your global, you have your route 1, 2, path control, then you have your first cog, second, third. You want the innermost one. So this is going to move our entire bike. So if I control select our model group and do a parent constraint. And I'm also going to use a scale constraint because we want it to scale as well. So now let's see what happens. Now the whole thing is moving. Our bike chain isn't coming with it, and we'll take a look at that in a second. Let's go ahead and rotate. It is rotating along. That's great. Cool. And if we scale, most of it is scaling. We still have to fix the bike chain. The bike chain's not working yet, and that is because I have a rig inside of there. So we'll take a quick look at that next. So let's focus in on this chain group. It's hidden right now, so I'm just going to I'm going to show it, and then we'll take a look at these curves. We won't go too deeply into this setup right now. I just want to give you a quick rundown and show you what you need to know to continue on with your constraints. So if we look at these curves, this is actually what is moving our joints. And we haven't gone over joints yet, or skinning for that matter, but just know that these are controlling our geometry. So we don't want to double up on our geometry being moved with a constraint here. So if you actually notice this constraint geo group, if I go into the attribute editor, you'll see that I've disabled inherit transforms. So actually we want to transform these curves. So to do that, let's select our third cog control and constrain this entire group. So we'll do the same constraint. So we'll use a parent and a scale. Cool. So let's go ahead and hide this again. We are going to want to use the large and small gear spin to constrain our gear geo, so that when we rotate our pedal, notice the chain is moving, but the gears are not. So let's go ahead and constrain these because they have already been set up to move. Let's make this a little easier to see. So we want our small gear geo. We're going to use the orient constraint again, and we want rotate X only. So go ahead and apply that. And then the large gear, do the same thing. And let's see if that works. Perfect. So now those are all moving together. Let's take a look at these pedals now. I want to be able to rotate this and have them remain flat. To do that, we actually need to constrain the group above this control. So if I go into the outliner and take a look at that, you see I have these pedal locators. So one thing we could do, first let me expand this a little bit. I'm actually going to want to unparent these so that they do not follow the transforms of this control anymore. So we're just going to move them by middle mouse dragging them above the pedal control constraint group. So we'll put them here. And now if I want to take this right pedal, and what I can do is point constrain to the right pedal's constraint group. So if I go to point, go ahead and say apply, and we'll do that for this pedal as well. Go ahead and hit apply. Cool. So now it's going to do what I want because it is following the translation of these locators I have here. There's actually another way we can do this without locators, so I'll show you that. And actually, I'm going to prefer to use this way just to have less nodes in my scene. So I'll go ahead and delete these locators. When you delete an object that is controlling another one via a constraint, it's going to delete that constraint. So now I no longer have the constraints that I put here. What I can do is select this pedal control, and then control click on one of my pedals, and let's do a parent constraint, but we only want the translation. If we do rotation, it's going to do the same thing that we had set up previously. We don't want that. So go ahead and do translate, and I'm going to do that for the right side as well. Hit G. So now we're just using a parent constraint from this So it knows where to offset the controls translation. So it's going to have the same effect, but we have fewer nodes. And that's the goal. Just a couple things I want to point out before wrapping up this lesson. On the global control, I've added an attribute called global scale. This is where you would want to uniformly scale your rig at the beginning of the scene before anything happens. So it's at the right size when you start. To do this, I'm going to connect the attribute into the other scale attributes. And from now on, we'll just be uniformly scaling from the global scale. Cool. So that actually does what I want. There's one more thing that I want to point out, though. This scale constraint that I added from this control is not going to work properly yet on the chain. The chain is set up to use global scale. So if I actually graph this node by graphing the output connections of the global control, we can see global scale is going into all these joints, into the scale Y and Z of each chain joint. What I'd actually want to do is replace it with the scale from the model group, but that's going to take a really long time. So this is something we'll get into doing once we start scripting, because we can do that very quickly. All right, that's all. Thanks for watching. And in the next lesson, we'll go over some things we can do to clean up this rig for animators. I'll see you then. In this lesson, we'll be making our rig a little bit more animation friendly. So let's start by cleaning up some stuff in the channel box here. If I were to just hit S to set a keyframe, and if I wanted to look at that in my Windows Animation Editor, Graph Editor, I can see there's a keyframe for everything. And if you're animating along, very quickly it's going to get pretty cluttered. So we really only want them to be able to key one axis, so let's get rid of the ones that they don't want. So just drag selecting them all and then hitting Control to deselect, then right click and go down to lock and hide selected. So now they can only access the rotate X, and if they were to set a key on that, it's only going to key rotate X, which is great. That's what we want. So now we can go to some of these other things like the pedals here and do the same thing. Go ahead and hit G. Make sure you're not actually typing in something, but G will repeat your last action. So G to lock and hide. Do that again for this one. This is going to be rotate Y, not X. So now we can only rotate X, which is good. We'll leave the tires, but we do want to remove this scale. And if you wanted to be able to scale your tires, just make sure to constrain using a scale constraint to that group as well. But it's probably not likely that they'll want to do that. So go ahead and delete that. Not delete, sorry, just lock and hide. So I'm also going to hide this graph editor and start going through the rest of the controls. So seat, we want to rotate and translate. Actually, we added scale, so we'll leave that. We'll just remove visibility. This one is just going to be translate Y. This is going to have scale. So hide only visibility. These ones I'm going to hide the scale as well and just allow them to only access scale on the global and on the innermost cog. So we'll go ahead and hide these. That's still there. So we'll do the same for these 4 controls. Go ahead and lock and hide scale and visibility. On the global, see we have these direct connections. We don't actually want to lock it, we just want to hide it. So right click and then do hide selected. We can lock and hide our visibility, however. And I think that's everything now. Our channels are pretty clean. We don't have that many controls. So let's go ahead and start setting up some visibility switches for the controls that we want to hide by default. I'm going to add an attribute on my cog control to drive the visibility of the controls beneath it. I'm going to do the same thing for the path, but let's first add an attribute. Go Edit, Add Attribute, and let's call it something like secondary control viz, and I'll copy this because I'm going to use it again in a second. We want our data type to be a Boolean, so that's either true or false, or in other words, on or off. So go ahead and add that, and we'll do the same to this control here. Go ahead and add. Cool. Now let's select the shapes. One way to do that is in our viewport, we just drag select and shift select the shapes that we want, and then use the down arrow key to pick walk down in the outliner. So you can see the result is now we have these shapes selected. Pick walking in the outliner, it just goes up or down in the hierarchy, and you can use the arrow keys to do that. So in the node editor, if I go ahead and just add those shapes here, then I also want to add the driver controls, which are these two. Go ahead and hit add. We're not concerned with these shapes right now. So first let's do the path, because I have that expanded already. I'll connect this, the secondary control viz, to the shapes visibility. See, that went away. And then we're going to do the same thing to these controls. So secondary control viz into the control visibility. And we'll do that again for this one. Now it's just a little bit easier to see things visually in our rig. And you can set that up however you want. It's better if you give animators less controls, because it's a little bit less overwhelming. Just as long as like the main functionality is there, it's represented in a main set of controls, and then underneath that you can add visibility switches to display more fine detail controls. Go ahead and clean up the outliner here. Take these and group them together. Control G to group. I'll call this rig group. And we can even group these together. Just call it something like bike anim. So it's an animation rig. Awesome. In the next lesson, we'll take a look at how we can add multiple targets to a constraint and then switch between them. Thanks for joining me, and I'll see you there. This should be a relatively quick lesson because the same principle is going to apply to all the types of constraints that we're looking at in this chapter. We know that to create a constraint, you first select your driver object, then the driven. But what if you want to drive your object with multiple targets? You then first select all your targets, and then select the driven object last. In this example, I'll use a parent constraint with maintain offset turned on. Go ahead and hit apply. You can see in the channel box, the parent constraint is created, and it has 4 targets, all with a value of 1. This means that each of the influences is evenly distributed. So if I were to move one target 4 units, my driven object is going to move 1 unit because we have 4 objects. So if I move the other one 4 units, it moves another unit. And if I move these 2 objects 4 units, then our driven object has moved a total of 4 as well. And if I select them all and move them back, it moves as 1. Because this is set to 1 for each target influence, it's actually getting an average. So each of these is getting 25% of the influence. So if I set it to 0.25, this is essentially the same thing. You'll see if I move this 4 units, our cube is still moving only 1 unit because one of our target has 25% influence. But if I were to turn off 2 of these targets, say the first 2, now each of these has 50% of the influence. So if I move this 4 units again, our cube is actually moved over 2 units. And if I move these 2 together, it's going to move the cube the same amount. So let's go ahead and undo that. And if you notice, when I turn these off, the cube didn't move at all. That's because maintain offset was turned on when we created this constraint. Let's take a look at what happens if you create the constraint without maintain offset. Let's go ahead and delete this constraint because we're going to recreate it. But this time, I'm going to select only the first two cones as my targets, select the cube last, and then I'm going to turn off maintain offset. If I hit apply, you'll notice that the cube snaps in between these two cones. By default, our target value is set to 1 for each. So that means that each cone is going to influence the cube 50%. So it's an even distribution for now. But also because we turned off maintain offset, if I go into my constraint and turn off one of the targets, it's going to snap to the one that is still on. If I turn the value, if I start dragging the value up on the second cone, it's going to get closer and closer and closer until it almost touches. This is a ratio, so if I go to 99, it's going to be 99% an influence of this second cone and 1% influence of our first cone. That's why it's not quite there. But if I turn this off, it's going to snap completely, and it's going to be the same thing as if I were to use a value of 1 per 100%. Using a reverse node is a great way to switch between two objects. We'll first need an attribute. For this example, I'm just going to put it directly on the cube. So I'll go to Edit, Add Attribute, and I'll call it Switch. Make sure it's a float value, and we'll set the min to 0 and max to 1. Go ahead and hit Add. And now I'm going to start dragging some things into my node editor. Here we have our constraint and the driven object, because this has our attribute, so we want that. I'll go ahead and expand both of these. I can see the targets are right here, which are these two targets. And I want to create a reverse node. So I'm going to go ahead and hit Tab and type in reverse. Reverse. And here's our reverse node. I'll expand this. And a reverse node is essentially 1 minus the input value. So if our switch value is set to 0, 1 minus 0 is 1. So if I put the output, let's put it in target 2, I believe is set to 1 right now. And then we'll take our switch, which is value 0, and put it into target 2. So now, if I select my cube with the attribute, I can middle mouse drag, and you can see the values on the target are switching. And this is a great way to switch between two different constrained objects. Up next, we'll learn how we can use aim constraints to build a simple iRig. I'll see you over in the next lesson. Hey everyone, welcome back. In this chapter, we'll take a look at how to build a simple eye setup using aim constraints. It took me a little bit longer to get comfortable with aim constraints compared to the other ones we talked about previously. So if it's not making sense right away, don't get discouraged. Aim constraints have more parameters than the other constraints. You can use these effectively without fully understanding them, but I'll do my best to give you some general knowledge. This type of constraint uses vector math. A vector measures magnitude and direction, but for aim constraints, we really only care about the direction. Fear not, we don't need to do any complex math to understand how to use these. In fact, you can actually use these to avoid having to calculate aim vectors yourself. Go ahead and open up the scene called Eyeball Aim Constraint in the course materials. To help you understand what a vector is, I've included a little setup that allows you to interactively draw a vector in the viewport. Our first vector, aim vector, starts at your driven object's pivot and points at the target. Because Maya is a three-dimensional application, we can represent a vector with x, y, and z values. Here, I almost always set one axis to a value of 1 and leave the other two at 0. My object's primary axis is the value I set to 1. In the case of my iRig, my primary axis is z. So I will change this to 0 and set my z-axis, x, y, and z, to 1. We can verify that this is correct by looking at my vector setup. If you drag the end locator around, you can see a change on these cubes representing the x, y, and z vector values. The arrow will point in the corresponding direction. So, if I move this arrow down the x-axis, you can see that this cube representing x becomes larger. Same if I move up, start to add some y, and if I go back to z, here it is. As I've said, a vector represents magnitude and direction. You can think of magnitude as the length of the vector. You can normalize a vector, which basically means to make the magnitude always equal to a value of 1. In other words, if I were to change my vector value from 1 to 5, my direction still has not changed, and that's the important part about aim constraints. So let's look at our eyes again. We know we want them to aim down z, but what is this up vector? You can think of this as your twist axis. It doesn't necessarily need to point upwards, but in this example it will. So we can actually just leave our up vector as positive 1 in y. There are a few different ways to control your object's twist axis. You can do this by changing the world up type. My preferred method is object up. I feel like it's the easiest and most flexible one to manipulate. For this, we'll have the up axis aiming at an object of our choosing. I've included some locators that you can use. I will copy my up vector locator name and paste it into the world up object text field. Now, this locator will control our twist. Let's now create our constraint. We want to use this eye target as our driver, and we'll want it to control our eyeball. But remember, we don't create constraints directly onto controls. So if I focus in on the outliner by pressing F, I can see I have this constraint group. Let's use that instead. First select the driver, then the driven, and hit apply. Now our eyeball aims at this target control, and this locator controls our eyeball's twist, which is exactly what we want. Let's try another method with the right eye. We'll drive our object's twist with the rotation of our head joint. So I'll just copy this name here. Instead of object up for the world up type, we'll use object rotation up, and I'll paste this name here. Then we'll select our driver object, then the driven, and hit apply. Very similarly to our left one. The main difference is that instead of using this up vector locator to drive the twist, we're using the head's rotation to drive the twist. Keep in mind that if the up vector crosses over your aim vector, your eye is going to flip, and you can see that as this passes over the eye guide. This isn't much of a limitation because if you imagine a head geometry, your eye is well inside of the skull at this point. Go ahead and play around with this scene for a while and try and get the same results. If you're feeling very adventurous and want to see how I did the vector setup, I would start by selecting these two locators, going into the node editor, and graphing your input and output connections. And that concludes our chapter on constraints. I'll see you in the next one to learn about joints and skin clusters.